We ended our previous video on composite functions, which was basically function of function. Now, iterated function is a special type of composite function where the function is performed on output of itself. The function is performed on output of the function itself. For example, if f of x is a function, then f of x or f of x will be iterated functions. Okay, this is also written as f of f1x, and this will be written as f2x, and this is f3x. Okay, now there are three things that you should never get confused with: f2x, fx square, and fx square. Okay, and these are the three things that you should never get confused with. Let's see the differences between them. f2x, this most often means f of x. Okay, but sometimes it also means f of x into f of x. This also means f of x into f of x, and this happens in very few cases, such as sin square x. Okay, that simply means sin x into sin x. Okay, or cos square x, or any other trigonometric function. So mostly in cases of functions in which x part is written without the brackets, in those cases you will see f2x as f of x into f of x. Okay, but generally in most of the cases f2x means f of x, f of x. Okay, this is the most common understanding of f2x. Okay, fx square, well, if f of x is x cube plus 3x, then f of x square will be, we'll put x square in place of x and we'll get x to the power 6 plus 3x square. This is what f of x square means. Okay, and f of x square, this simply means square of this function. Okay, this is nothing but f of x whole square, which also means f of x multiplied by f of x. Okay, so you should never get confused between these three. Now let's take an example. F of x is equal to 2x plus 1, and we have to find f3, 2. Okay, f of x is 2x plus 1. This is nothing but f1x. Okay, let's find f1, 2 first. So in place of x, we will write 2 in the left hand side as well as right hand side. So we'll get 2 into 2 plus 1, that is 5. Okay, f2, 2 will be f of f12, right? f12 is 5, so this is equal to f of 5, which we'll get by putting x as 5 here. That will be 2 into 5 plus 1. 2 into 5 plus 1, that is 11. f3, 2 will be f of f22, right? That will be f of f22 is 11, f of 11, which is 11 into 2 plus 1, 23. Now if you have got the pattern, then this 23 will become input to this function again, and we'll get f42 as this 23 will go in place of x here, and we'll get 2 into 23 plus 1, that is 47. Now for f52, this 47 will be input again, and we'll get 2 into 47 plus 1, that is 95. Okay, like this will go on. We were asked to calculate f32. This is our answer. Next question. F of x is given as x cube, and we have to find f18x. So this is nothing but f1x. Okay, f2x will be f of x, that is nothing but f of x is x cube, f of x cube, and for f of x cube we will write x cube in place of x here. Okay, we will replace this x by x cube and we will get x cube whole cube. Now a little property of exponents: when power is raised to a certain power, the powers get multiplied. Okay, this 3 and 3 will get multiplied and we'll get x raised to 3 into 3 or x raised to 3 square. f3x will be f of f2x. Okay, that will be f of f2x is what? X raised to 3 square, which will be equal to, we'll put x raised to 3 square in place of x here and we'll get x raised to 3 square whole raised to 3. Again powers will get multiplied, x raised to 3 square into 3, that is x raised to 3 cube. So for f3x we got x raised to 3 cube. For f2x we got x raised to 3 square. So for f18x, continuing this pattern, we will get x raised to 3 raised to power 18. Next question. F of x is given as x minus 1 upon x. We have to find f47x. So f2x will be f of x, right? F of x is x minus 1 upon x. That will be f of, we'll write x minus 1 upon x here, x minus 1 upon x. To find f of x minus 1 upon x, we will have to put x minus 1 upon x here in place of x. Okay, if we want f of x minus 1 upon x, we'll have to replace this x by x minus 1 upon x, and in the right hand side also we will replace x by x minus 1 upon x. So we'll get x minus 1 upon x minus 1 upon x minus 1 upon x. This is nothing but x minus 1 minus x upon x minus 1 upon x, and on cancelling we will get minus 1 upon x minus 1. Okay, f3x will be, we'll put this in the input here, we'll put minus 1 upon x minus 1 in place of x here to get f3x, and that will be minus 1 upon x minus 1 minus 1 upon minus 1 upon x minus 1, which will come out to be x. f4x will be equal to, we'll put this x in place of x here and we'll get x minus 1 upon x. So f1x is x minus 1 upon x. Okay, and again on applying the same function third time, this was first time, second time and third time, applying the same function third time, we are getting f4x as x minus 1 upon x. We are getting the same result. So the cycle is of 3. Between f1x and f4x, the gap is of 3. So the cycle is of 3. Here after f1x, we got x minus 1 upon x, and f4x is giving x minus 1 upon x. After f4x, f7x will give us x minus 1 upon x. Okay. After f7x, f10x will give x minus 1 upon x. This is what cycle of 3 means, right? After every 3 iterations, x minus 1 upon x will repeat. f1x, then f4x, then f7x, f7x, then f10x. Gaps are of 3 only, 3 units. Okay. To get f10x directly, we will divide power of 10 by 3. 3 is our cycle, so we will divide power 10 by 3 and the remainder will come out as 1. That simply means f10x is equal to f1x. Okay, this remainder is 1, that means f10x is equal to f1x. That is nothing but x minus 1 upon x, which we can see here as well. Okay. Now we want 47th term. We want f47x. That is the 47th term. Okay, we want this. So we'll divide this power of 47 by our cycle, that is 3. So 47 upon 3, remainder will be 2. That means the second term is what we will get after doing this iteration 47 times. So f of 47 of x, f47 of x is equal to f2 of x, which will be equal to f2 of x is minus 1 upon x minus 1. Okay. Better understanding of this question will come once you go through last digit calculation video in number system. Now let's say we want 54th term, f54x. Okay. 54 divided by 3 will give remainder as 0. 0 means third term. Don't get confused in this. Okay. On dividing by 3, any number will give remainder either 0, 1 or 2. Okay. We'll get 0, 1 or 2 as remainders. 1 and 2 means first term, that is f1 or f2. 2 means f2 and 0 means f3. So f54x will be equal to nothing but f3x, and f3x is x only. Okay, so f54x will come out as x only. Moving on to next question, which is from CAT 2000. Just pause and go through the question once. We are given a condition here. If x is greater than 0, our function will be defined as 1 upon x, 1 plus x. If x is less than 0, our function will be 1 plus x. And what is this here? This is nothing but definition of iterative function, right? f4x will be what? F of 4 minus 1, 3x. This is what iterated function is. Okay, so this is nothing new. Let's find out f3x, f4x, f5x and so on till f10x for x is equal to minus 1. First of all, our x is less than 0. So we'll proceed with this branch. We'll proceed with this definition of function. So f1 of minus 1 will be 1 minus 1 plus x, x is minus 1. So we'll write 1 minus 1, that is 0. Okay. f2 of minus 1 will be, now we'll write 0 in place of x here. Again, because our input is 0, which is less than or equal to 0. 0 is less than or equal to 0. So we'll take this function 1 plus x. So we'll write 1 plus 0, that is 1. Now our input is greater than 0. So we'll take this branch now. Okay. f3 of minus 1 will be 1 upon 1 plus 1, that is 1 by 2. f4 of minus 1 will be, now this 1 by 2 is again greater than 0. So we'll move with the first branch. 1 upon 1 plus 1 by 2, that is 2 by 3. f5 of minus 1 will be 1 upon 1 plus 2 by 3, that is 3 upon 5. Okay. Similarly, f6 of minus 1 will be 1 upon 1 plus 3 upon 5, that is 5 upon 8. Now let's write this product. This product is equal to f3x, that is 1 by 2, into f4x is 2 by 3. For x is equal to minus 1, we are writing this. Then we have 3 by 5 and then 5 by 8. And let's identify this pattern. This 5 by 8 is what? f6 of minus 1. Okay. Now this denominator is going to the numerator in the next term. So in the next term we will have 8 in the numerator, and for denominator we are adding both numerator and denominator of the previous term. So 1 plus 2 gives 3. This 3 will come in the denominator here. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 will be 13 here in the denominator. Then this 13 will go in the numerator, and we'll have 8 plus 13, 21 in the denominator. then 21 in the numerator, and 13 plus 21, 34 in the denominator. Then we will have 34 upon 21 plus 34, that is 55 in the denominator here. All these will cancel each other, and what remains is 1 in the numerator and 55 in the denominator. So we will have 1 upon 55 as the final answer. Okay. Now what if instead of this, instead of starting from f3x, if the product started from f1x, if we had f1x into f2x into f3x and so on till f10x, what will be the answer then? Well, the answer will simply be 0, as f1x, f1 of minus 1 is 0, so it will make this whole product as 0 only. Okay. So in this way, even if cases are there, we can deal with iterated functions easily.